Finding the prime factorization of numbers is the process of finding a set of prime factors that multiply to get a multiple. In the two examples listed on the board, 27 and 108, we used a process called the factor tree, or I use a process called the factor tree to find the prime factorization of 27 and 108. First of all, 27 is considered a composite number. What makes it composite is that it has two or more factors that you can multiply to get 27. 1 and 27 is one factor pair that you can multiply to get 27, and 9 and 3 is another factor pair that you can use to multiply to get 27. Therefore, 27 will be considered a composite number. Well, on the factor tree to find the prime factorization of 27, we use 9 times 3. 9 can be further broken down, however 3 cannot. That is the reason why it's circled on this tree. 3 is a prime number because it has exactly two factors, one in itself. So the only way to make 3 is 1 times 3, which will make 3 a prime number, and so we circle it on the factor tree because all prime numbers get circled on the factor tree. 9 is a composite number that can be further decomposed or broken down, and so we put these legs or branches underneath 9 to show that we can decompose it because it is composite. So 9 has at least 2 or more factors. That makes it composite. So we use 3 times 3 to make 9 because we don't want to use 1 times 9 because we don't want to use 1 on the tree. Or we generally don't use 1 on the tree. So we're going to use 3 times 3. Once again, 3's are prime numbers, so we circle them, indicating that they're prime and they cannot be further decomposed. Once we have all prime numbers, which every branch on the tree has a prime number under it that cannot be further decomposed, then we know we are done. And so the prime factorization of 27 can be written as 3 times 3 times 3. And if you write that in exponential form, the prime factorization of 27 is 3 to the third power. 108 can be decomposed because it's a composite number. It has 2 or more factors. And the factors that I chose to use to make 108 is 12 times 9. There are other factors that you can use to make 108. I just chose 12 times 9. 12 is a composite number because it has 2 or more factors. So we decompose it, which means we give it some branches underneath. I chose 4 times 3 to use to break down 12. You could have used 6 times 2 to make 12, but I chose 4 times 3. So 4 times 3. 3 is a prime number because it has exactly 2 factors, 1 in itself. So the only way to make 3 is 1 times 3. 4 is a composite number, and so it gets more branches underneath because it can be further decomposed or broken down. To make 4, I use 2 times 2. Well, 2 ends up being a prime number because it has exactly 2 factors, 1 in itself. 2 is the only even prime number as well. So there are no other numbers that are even that are prime except 2. So 9 can be decomposed and we use 3 times 3 to make 9 because the only other way to make 9 is 1 times 9, and we don't generally use 1s on the tree. So we use 3 times 3, and the 3's get circled because they are prime numbers. The only way to make 3 is 1 times 3, so we circle the 3 to show that it is prime. Since there are no other numbers that can be decomposed, no other place to put branches to break down a number, we are done. And therefore the prime factorization of 108 is 2 times 2 times 3 times 3 times 3. And if we wanted to write that using exponents, we write that as 2 squared, or 2 to the second power, because there's 2 2's, times 3 cubed, or 3 to the third power, because there's 3 3's.